Hello, everyone who joined and those online later who will be watching. Hello to you too. Welcome to the June 2026 live stream of the ArcGIS Maps SDK for native apps, where we're going to be talking about what's new in 300, the very latest version. And it is chocked full of so much good stuff that we are so excited to talk to you about today. Mainly today, there's a lot of stuff. We're only going to be chatting today about the new spatial analyst APIs, uh, local scenes, and editing. I shouldn't say only. That packs a punch right there. That's a lot. But there's just a lot that went into this release. So for anyone unfamiliar with native SDKs, they are all about bringing mapping functionality, mapping capabilities into native apps, like for your phone, for any device really. Um, iPhones, iPads, Android phones, Android tablets, desktops, Mac, Windows, Linux. So they really are all about like taking advantage of your operating system on those different devices. And for example, like on the phone, you can use the GPS, you can use the accelerometer, anything on the phone pretty much. So that's what native apps are all about. You don't need to go through a web browser. You can go offline. So that's what kind of sets them apart. Also, you can do some cross development. What's it called? Develop once and deploy anywhere. That's another distinguishing feature of our native apps SDKs. Just to let you know too, they come in a couple flavors. They come in 5 different flavors: Flutter, Swift, .NET, Kotlin, and Qt. So you can develop in what you're comfortable with or what your company uses. It's pretty open to you. So one other kind of distinguishing feature I think is worth mentioning is that it's part of the big super secure ArcGIS platform. So you get all the advantages of that, and you also get to maintain full ownership of your data and your full control over your data. So that is what native apps are. So let's dive right into what is new in the latest version, which is 300. And as we show you these features, we'd like you to put in the comments where you're from, maybe what feature you use a lot. What we're going to do is introduce ourselves now and dive right into it. And as we introduce ourselves, we're also going to tell you a fun fact about ourselves. And the fun fact today is, what was our first Esri product we ever used? Okay, so I'm going to kick it off. I'm going to start with me, and I'm Mara Dolan. I'm a product engineer. I work on the developer outreach team, and my first Esri Esri product was ArcMap when it was very first born, 27 years ago. Embarrassing, but that's the truth. It was for a utility app that the stuff I did sat on top of Arc FM. So shout out to Snyder Electric out there. But yeah, that's me. So I am going to hand it over to Lucas to introduce yourself.
Okay, thanks, Mara.
Sure.
I'm Lucas. I'm a product engineering lead. I am product owner on our Maps SDK for Qt team. I've also worked extensively on our editing capabilities, specifically geometry editing, over the last few years. And my first Esri product was ArcMap 9.3 and my intro to cartography, Geography 370 at UW-Madison. Yeah, it's when I fell in love with maps. So I'll pass it over to Mark. You can introduce himself next.
Thanks, Lucas. So, yeah, I'm Mark, and I'm based in Edinburgh Research and Development Centre, and I work in our runtime core team looking at parallel processing techniques. Now, my first application I used, I've been sticking dots on maps for a long time. It's probably ArcInfo Workstation with AML, but I've also used Avenue and MapObject and Engine. So, yeah, all of them. So, who shall I hand over to next? Yulia.
Hi, I'm Julia. I'm a software developer in the backend of the Maps SDK, and like Mark, I'm working on the GPU spatial analysis programming. Yeah, and my first, I guess, product was working with Maps SDK with Kotlin and just trying out making apps, basically. Yep, and I'll pass on to Hudson.
Thanks. Yeah, I'm Hudson. I'm a software developer. I've been pretty heavily involved in the Kotlin and Android SDKs, Android before the Kotlin SDK. And the Android SDK was my first Esri product, the ArcGIS Maps SDK for Android.
All right. Thanks, everybody. And I see in the comments, people are joining from Coventry, UK. So we've got some folks over with you there, Mark, kind of in your area, kind of. So yeah, we'll just please. I didn't mention in the intro. I meant to. We are so excited to hear from you. So please don't be shy in the comments. We'll keep in touch with you there. All right. So let's hand it right over to Yulia and Mark. Actually, I think Mark, you're going first. Correct?
I will. Yes.
Do it.
Okay. Right. Oh, thank you. So in the 300 release of the Maps SDK, which came out just a few weeks ago, we introduced a new high-performance analysis API. Now, this is something which is going to grow over time, but the first functions we included here were view-shared, line of sight, and map algebra functions. And you can run these against raster, elevation, or field data. So I work on the team that helped to create this alongside Yulia. And in our team, what we like is a challenge where we can take something which is computationally expensive and potentially slow and make it work really fast. Now, traditionally, this has involved writing multi-threaded CPU code. Now, this will take you so far, but you're always going to be constrained by the number of CPU cores. So what we've done is we've taken things a stage further and we've moved the processing to the GPU. So you can go from just a handful of threads to potentially many thousand, depending on your hardware. Now, this is really satisfying work. So you can take some CPU-based code, which might take a few seconds or even minutes to come up with the result. And through the use of compute shaders, you can whittle this down to literally a few milliseconds. Now, under the covers, we're making use of a library called WebGPU and WGSL compute shader language, which is very similar to Rust. And this is a cross-platform library, so it works on the mobile and the desktop native platforms that we support. Now, this makes it a really suitable platform for gradually replacing the functionality in the now deprecated local server, which of course only worked on Windows and Linux. So enough about the technology. What I'm going to do now is hand you over to Yulia, who's going to give some demonstrations of this new functionality in action.
Thanks, Mark. So yeah, I will demonstrate the performance of the new analysis API for you using the new line of sight functionality. So I'll just share my screen. So here we're on the Isle of Arran in Scotland. And you can see here the elevation data is being rendered in a scene view. So let's say we want to, we have a radio tower and we want to find a good position to place this tower so we can track the visibility between the tower and some search and rescue teams. So for the simplicity of the demo, I will first place, the search and rescue teams in a circle, and I will do a line of sight analysis between the search and rescue teams and our radio tower. So the first analysis is a bit slower because we have to transfer the elevation data onto the GPU. Usually it should be around like 100 milliseconds, but because I'm also screen sharing and my camera's on, it might be a bit jittery. But when the elevation data is on the GPU, the subsequent evaluations of the line of sight analysis is very fast. As you can see, it's 1 to 2 milliseconds for 4 lines of sight for our 4 search and rescue teams. But we're not just constrained to 4 lines of sight, we can try more. So for example, now we have 10, we can see the performance is around 2 milliseconds. Now 100. Oh, my is a bit jittery, but it should be relatively fast. But if I wasn't screen sharing, it would be around also 2 milliseconds. Let me just quickly turn my camera off. Maybe that will help. Yeah, there we go. So we're back to good performance. Now 1,000 lines of sight, you can also see it's around 10 milliseconds. So the performance scales quite well. I will now turn my camera back on. So this analysis is being done at the full resolution of the data. Here it's 10 meters and the circle of target positions. They are around a radius of 10 kilometers. So you can use this analysis to both do more exploratory analysis and also more scientific analysis, or both. Now, staying on the Isle of Arran, I will now show you an app. Oh, sorry, 1 second. So we have this app using the Flutter SDK, where we can create a viewshed for different positions for where we might want to place a fire watchtower. So as I click around on the island, the viewshed updates with the new positions. So the viewshed function gives us some extra parameters that we could use. For example, we can update the field of view. We can change the heading angle. And we can also change the maximum or minimum distance that we are calculating the viewshed over. So we can also use the map algebra functionality to do further analysis. So for example, if you have some land cover data, we can combine this with the viewshed to categorize the visible areas. So I shall do this now. Now you can see the viewshed is more colorful. And if I scroll up on the app here, you can see which color represents which land category. So now we can take this further and use the map algebra functionality and the viewshed function to combine the two. So what we can do is show both the visible areas that are visible to the fire watchtower that are susceptible to wildfires. So you can see the viewshed is updated with that. So if I zoom in here into this around this lake area, you can see as I change the analysis, we exclude some of those areas. Then once we are happy with our viewshed, we can actually export it to a file as a raster. So I've saved this now to my phone. So for example, if you would want to share it with your colleagues or do further analysis using different applications. And like the line of sight functionality, this was also done at the full resolution of the data at 10 meters. So again, you can do scientific analysis if you need to. And it's also completely independent from the visualization of the visualization. So you can pair it together, but you can also do the analysis without visualizing it. So hopefully I've shown you a bit of a taste of the new API and the functionality and the performance it brings. And now I'll hand you back to Mark, who will show you how you can get started.
Thanks, Yulia. Some great demonstrations there. So I'm going to share my screen. And I appreciate people looking at the demonstrations that Yulia did there. You're probably thinking, how can I bring that into my own applications? Well, it's fairly straightforward. The best place to start off with is our developers website. So if you go to developers.arcgis.com and to one of our native APIs, so I'm looking at the Flutter API in this case, there's a spatial analysis page that you can use to start learning about this functionality. And this includes the high performance analysis that we've been showing, but also other existing areas like routing and geocoding, for example. I'm going to scroll through to the bottom because the thing I like most here are the sample applications that we've written. So if I click on the map algebra sample, for example, this is a complete application that's available open sourced in GitHub, and you can take a look at this functionality. It's going to reclassify some raster data in this case. And if you like the capabilities inside this app, just take the source code and bring that into your own application. And you can do that in the knowledge that you're applying best practice for making use of our API. So this is just the start of this new analysis API. We are going to be adding in more capabilities in future releases, and we're initially going to be focusing on popular functionality, focusing on surface and satellite analysis data. But if there's something you'd like to see added into the API, then let us know. I'd really like to hear about what you'd want to include in your own applications. So with that, I'm going to hand you back to Mara.
Thanks so much, you guys, Julie and Mark. That was great information, and I want to just emphasize that I've seen in multiple places, I think, blogs, like, we really want your input on what tools you would like to see, and if you're not sure if it's great for a tool, just like, what would you like to see? But we're really seeking input on geoprocessing tools. And just a quick note on someone who's written in, Sideman 5607 is making me feel young. The first Esri GIS I used was ArcView 1, basically a viewer, but a desktop PC application, early 1994. I learned digitization in Atlas GIS in 93. I know ArcView, but I am not familiar with Atlas. Are you guys? Atlas GIS? But I think I might be the oldest anyway. I should have heard of it. Okay. So we'll move on to Hudson is next. He's going to talk to us about local scene support and building scene layers. Thanks, Hudson.
Thank you, Mara. Let me just share my screen here. And 1 minute. There we go. Right, so the native Maps SDKs have supported global 3D scene workflows for a really long time, but now in the V300 release, we've got some new capabilities for working with scenes on a much smaller, like, site or project scale. And this is really useful, particularly for projects in industries like architecture, engineering, and construction. So what we're looking at here is a application built with the Kotlin SDK. And here we're actually looking at a global scene. So global is really useful because you can view a variety of different layer types within that Earth scale context in one 3D view. So if I zoom out here, you can really see that Earth scale context because we have an actual globe and we can go anywhere in the world. And using this is the same as ever. You just create a scene and pass it to a scene view. But now you can specify the scene viewing mode as global. And that just indicates that this should be used with the global scene view. And the thing is, sometimes you really don't need that global context. We don't need to see the whole world. And so you can change that to a scene viewing mode of local and pass it into a local scene view. And this is really optimized for those smaller scale precision workflows. And a local scene is basically 3D on a flat plane, and it uses a projected coordinate system. And part of that local scene model is you can also add a clipping area around the area of interest. And this can help improve focus and also improve the performance. And actually, I also want to mention here, thinking about performance, the local scene view is actually built on the same rendering architecture that drives our game engine SDKs. And so as I do some interactions here, you can see that it's really responsive. So now let's imagine that actually we're visualizing a campus and we want to add a new building to it, for example. And for that, we can use another V300 capability that we've added, which is the building scene layer. And a building scene layer is designed to display BIM-derived building model data. And here we're just looking at a building shell, so we can see the building within its context. But the power of a building scene layer is really unlocked whenever you can see all of the structure and components of a building model. And we can see what those structure and components are with just a normal identify workflow. So we call identify when we do a tap. And you can see here, I tapped on one of the exterior wall constructions, right? So we're getting a really precise level of data. Now, with so much complexity in this model, it can really help to be able to filter it in order to understand it better. And so we can filter what gets displayed based on a few different things. For example, the building level, the phase of construction, or different categories. Here, I'm filtering out to just show the lower levels and put the upper levels in a sort of X-ray mode so we can see through and see what's going on down on the floor. And creating a building filter is really simple. You just create it by supplying a few different building filter blocks here, which are built around these where clauses. And then you pass that filter to the building scene layer's active filter property. So to summarize, local scene view and building scene layer enable really precise site, campus, or city scale workflows within 3D, but they're designed also to sit alongside our existing global 3D capabilities. And I'd also like to just call out that everything I've just displayed here, we have samples to show you how you can implement these different features. And also, because local scene view and global scene view are designed for different workflows, they have a slightly different set of capabilities available to them. And so here on our Scenes 3D doc on our Esri developer, you can see some information about which layer types and which capabilities are available on each view. And that's it for me. So back to you, Mara.
That was so great, Hudson. Thank you. And just such cool stuff to look at, too. I am going to look at the comments and lean into everybody's favorite topic, age, and how old people are. Just kidding. But we had another comment. OCAS Ocas, 1962, started his career using AML. I think that I am the oldest, he or she says. I was pretty good at ArcInfo. And I should clarify, I actually was around for those, and I just realized I kind of called someone old. So the other person, I actually was only 2 years off of the first person we chatted with. So hope I didn't make anybody feel bad. We're not old. We are very young. Number 3 youngsters. I love that. Yeah, so that's awesome. AML, I do remember those days. I didn't work on it, but I worked on the UI side of things. Okay. Sorry. Oh, the links are in the video description. Someone backstage is telling me to let you guys know the links are in the video description. Okay. All right. So next up is Lucas. He is going to speak with us about editing and I believe true curves and some templates possibly, I think. Okay, awesome.
Yep.
Take it away, Lucas. Thank you.
Nice. And you're not old. You're experienced, Mara.
Thank you. Wise. Yes.
Wise. I've learned that it's hard to flex your Esri skills around here because so many people have been using the software forever.
I know.
Which is awesome.
It is good.
Yeah. Okay. I'm going to talk about 2 editing enhancements that we've made in the 300 release. The first one's called group and preset templates. And I think the one of the key things that I want to convey here is that when we build editing capabilities into the native Maps SDKs, we really take a mobile first design approach. And that's because GIS is kind of complicated. There's a lot of things to learn. There's a lot of nuance there, and trying to do complex workflows like editing on a tablet or a phone, it's pretty challenging. And it's not just challenging because the screen is small. It's challenging also because of the input device, which for most touchscreens is going to be your finger. When you're working on the desktop, you have a mouse, you have hover, you have a very precise point on that mouse. But if you think about your finger, it's probably about 50 pixels, give or take. So whenever you tap on the screen, you've got a pretty low chance at hitting exactly where you want to be hitting every single time. You also are covering up whatever you're trying to interact with your finger. And so basically, the more taps you're doing on your map when you're trying to do precision editing, the more room you have for errors. So that's where group and preset templates come in. They really complement some of the other features we've been adding over the last year or two. And for an example here, we're looking at a gas network. So down Tupelo Drive here, so this is Tupelo Drive, we've got this main gas line. The gas line comes from the utility company, it runs down your street, and then in order to heat your home, in order to run your stove, you need to have a service connection. And the service connection is more than just a pipe. You can't just butt 2 pipes together, right? You need to have a fitting. And so that's where you actually have this T connection. There's also this feature here, an excess flow valve, which is a safety measure. And then up at the top, you have the service meter, and that's what tells the gas company how much gas you've used. So all of those features, if you're in an editing scenario, you need to create all 4 features. And not only do you need to create them, they need to be in the right order, they need to connect to each other. All of those rules are sort of on the end user to make sure they follow. So let's take a look at the workflow before group and preset templates. I think it'll help illustrate really the value of group and preset templates. So this is how traditionally you would do it. You'd publish templates, feature templates. Good old feature templates have been around for a bit now. In this case, I've got a service pipe. So I'll go here, and first thing I want you to notice is the crosshair. That's what we call the reticle. The reticle is a geometry editing tool that we have created to help you see the edit that's happening without your finger. Like, don't have any hands on the screen. I can see if I press that blue button, I know exactly where that point is going to drop right now. And I've also got snapping enabled. That's the the gold feedback that you see on the screen. That gives me confidence that if I tap the button right now, it's actually going to snap to that line. So I'll drop 1 point, drop another, submit my edit, and I've created my feature. But the problem is I've just created 1 feature. I've got to create 3 more now, and I need to put them in the right location. So that means more taps on the screen, more chance for problems. So next I would create the T. I need to go up here. Now I know as a user, I'm supposed to have this at the intersection, but there's nothing in the user experience that stops me from adding it here. So I could add it there. I'd eventually find out there's a problem once we did a trace or once we pushed it, someone did some QA on the back end. But really, a great user experience on a mobile device helps you make the right edit in the first place. And that's what group and preset templates do. So I'm going to search for my service pipe group template. That group template will basically group together 4 different templates into one with some rules built in that will define where everything will draw. So I've got my reticle and snapping again. I'll add a 2-point line. I'll submit my edit. And then we have all 4 features created at once. I could even go in, and edit each individual feature further if I wanted to make some attribute edits. So that is group and preset templates. Now the next thing I want to show is over here on my Android device. This is True Curves. So we've supported True Curves in the product for a number of years now, but it's always been an opt-in feature. So if your feature services had curves, you would have to set a flag that said, I want to be a True Curve client. The big change with 300 is that now curves are the default. If your data has curves, we're going to fetch them. And that's really because the rest of the system now is coming up to speed and having curves supported throughout. And so we're basically making the leap that true curves are now a first-class citizen in the native SDKs. If you're not familiar with a true curve, think about a polyline or a polygon, typically a bunch of vertices, and between each vertex, a straight line segment. A true curve basically can have a mathematical curve between two vertices. It could be a circular arc, elliptical arc, a Bezier curve. And basically, this allows you to better model the real world. In this case here, we're looking at a railway in Portland, Oregon. But equally, it could be a cul-de-sac, a pipeline. In the real world, things aren't densified with a bunch of small jagged lines. They have nice curves defined. So the big change is that now you get curves by default. Second big change is that we can now take them offline. So I just press this button here. It's going to make a request to the feature service to create the replica with the curves instead of densified geometries. Now we've got this. When I zoom in again and I identify, you can see I still have a curve defined between those 2 vertices. The third improvement is that we can now edit this as well with the geometry editor. So I'm using my reticle, I'm selecting a vertex, I'm moving it, and that curve is retained. Now, if I were to use other geometry editing tools, I could also resize and rotate and move them as well. And in the future, we're looking to add interactive capabilities so you can actually create and edit curves interactively by changing some of the parameters. And last but not least, I don't have a demo for this, but we do support curves in 3D display as well now. So that's what I've got for you. I've got the true curves and the group and preset templates, and I'll pass it back to Mara.
Thank you so much, Lucas. Those look great. I was looking at I don't think we have any comments, but if anybody would like to ask questions to our developers on these topics or even other topics, but we've got the experts here for these topics: spatial analysis, local scenes, and editing, and true curves, templates. But if there aren't any at the moment, I will continue on and talk about. I'll talk about let's see here, the upcoming events for us, which one is, I believe it's the final one in the series of the Federal Technical Webinar Series, and the link will be in the chat, and I believe it's also in the description, or will be. And it's called Designing and Implementing Modern GIS Systems, and that is June 30th. And we also have, of course, our big user conference coming up. The UC is on July 13th and through 17th on this July 2026. So hope you can make it to one of those events or one of the many live events we have. We have another comment. Sideman5607 says, since a spiral curve can be represented by a Bezier curve, that covers railroads well. Yeah. Yeah, Lucas, did you want to? I think that's a great comment. Because
yeah, I mean, I guess I'll just say I think curves better represent the real world in general. There's numerous different cases, and as I mentioned, we've supported curves forever, so nothing's really new there. It's just that we're now bringing it to the forefront and getting them by default. So oftentimes we find that the users that know about curves or that it's important for their use cases, they know about it. They're trying to push it up to the feature services and then consume them in their apps. It's very important. But what we're really trying to do is round out all the little nooks and crannies in the API and make sure that the geometry engine methods, the geometry editor, all these capabilities can work seamlessly with curves and really give the tools to developers so that they can build great experiences around it.
Yes, and I see another comment from Liz LLOZ. We have been having issues with editing templates actually committing. Wonder if those issues have been flagged with those group and preset template tools or addressed.
Yeah, it's a good question. I'm not totally sure on that specific case. The template features shouldn't have any impact on your ability to commit them or not. There are some new capabilities coming in a future release to work offline, and that depends on certain versions of Enterprise. So, depending on whether you're working online or offline, maybe there's something going on there. Not too sure, but we definitely, reach out on Esri Community forums, and we've got the dev team there to help with any problems that you're hitting.
And we can answer in the comments here too, as soon as we get the answer. Yeah, the more detail you can add to your question, the better too. Well, thank you everybody so much. If there's no further comments or questions, I think we'll call it a day. And thank you guys so much for joining. Thank you presenters. Thank you backstage folks. Thank you mostly for you attendees for coming to see what's new in ArcGIS Maps SDKs for native apps. We really appreciate it.